Okay, welcome to the Sports Science Supplement, and today is an introduction to biomechanics. You are going to name Newton's 3 laws, memorize and write each of these laws word for word, and apply each of Newton's laws to sporting examples. Okay, so biomechanics as a whole is an underlying technique of science. The idea of it is to allow performers to understand exactly how to perform movement, and also to universally describe forces and explain forces that are happening to that athlete or object. So the very first advocate was Leonardo da Vinci, okay, or at least sports science. There are 2 subcategories of biomechanics, okay. So mechanics obviously relating to the engineering aspect, bio meaning the body and hence biology. Okay, so we have kinetics, which is concerned with the forces or result from the motion of bodies. So gravity, how it acts on the body itself. The muscles, what forces they produce. Likewise with friction, how does that impact the motion of the body itself? And we'll come to that in the next video on free body diagrams in more detail. Also kinematics, okay, so this is regarding description of motion. So displacement versus distance, or velocity and acceleration. Okay, again, these terms will be covered in later videos. So, very famous saying by Leonardo da Vinci: those who are enamored of practice without science are like a pilot who goes into a ship without rudder or compass and never has any certainty where he is going. Okay. Laws of motion, they govern motion. So Newton came up with the first law, was law of inertia. So a body continues in a state of rest or of uniform, identical velocity unless acted upon by an external force. So for example, you could have a football on a penalty spot. That football will stay there until it is kicked. Likewise, once the ball is kicked, okay, it will continue if it was in space, for example, at that same speed or velocity unless it was hit by another object, i.e. a goalkeeper. But obviously on Earth we have air resistance and gravity, which might affect the velocity of the ball. They are 2 forces that might impact the ball. Like I've said below, the universe is lazy, so the fact that it takes force to get it going, it also needs force to slow it down, stop it, or speed up or change direction. So this is more of a explanation of what I've just said. Newton's second law of acceleration. Okay, when a force acts upon that object, so for example the football on the penalty spot, the rate of change of momentum experienced by that object, that football, is proportional, i.e. is related to the size or magnitude of the force, and takes place in the direction in which that force acts. So if, for example, Mbappe kicked the football and it's heading towards, and he's directing it towards the center of the goal, okay, and he's kicked it right through the center of mass of that football, okay, if he hits with a certain force, then that ball will travel in relation to how hard he has kicked that ball. Okay, I've gone with the example of Ronaldo passing the ball to Dybala's feet. Okay, so in order for Ronaldo to pass over a greater distance to Dybala rather than a short distance, he needs to apply a greater force. So that is the law of acceleration. Okay, it's related to the force and the impact to it, to the object. The third law: for every force that is exerted upon by one body on another, there is an equal and opposite force exerted by the second body on the first. So this is the most famous law, and it's the law of reaction. For every reaction is an equal and opposite reaction. Okay, so remember that if you can't remember this entire definition word for word. The examiner will provide you that mark because you are correct. So an action force versus a reaction force. For example, if Ronaldo imparted Newton's first law, it's an action force to push downwards into the ground. The ground itself acts as the second body. Then he pushes down. That second body, which is the ground, actually provides a reaction force. It almost pushes Ronaldo up into the air. Okay, I've also said no, this force is proportional to the force applied to the ground. So if Ronaldo imparted a greater force in his second jump, he would jump a lot higher. Okay. Force without motion. Okay, no motion without force. So Arnold Schwarzenegger here, apologies, standing still, and obviously his action force is through both legs because he has two contact points with the ground. Weight due to gravity, and then reaction force is equal to all three arrows together. Okay, hence why I'm so take note of the lengths of these arrows. Do weight and action force equate to reaction force? Yes, they do. Okay, if reaction force was greater than gravity and the action force due to his muscles, bend and knees, then he would actually be jumping into the air, moving upwards. Okay. If you have any questions, please leave comments. Likewise, please like and subscribe. More videos will come out.